Welcome back. Today we're going to be starting Chapter 2. Before we get started into the new material in Chapter 2, I'd like to have this start up just to kind of remind us of some of the things that we were recently working on. So I'd like for you to try this and then check your answers in after pausing the video. Okay, on the first one, you're asked to find the zeros. If you remember, the zeros are the places it crosses the x-axis. So that's going to be this location, this, and this, and so that's going to be -4, 0, and 1 as our answers. The next part, we're asked to find where the function is greater than 0. That's where it's above the x-axis, so that's going to be this interval in here, and then also this interval over here. So our zeros basically cut the graph, and so from -4 to 0, our function is going to be positive, and then again from 1 to infinity. And so that's why we would write it like this, -4 to 0 and 1 to infinity. Here we want to find where these two graphs intersect, so we'll put this one in for y1 and this in for y2, and then go through the process of finding the intersection by doing calculate, and which is second trace, and then go to the intersect choice on the menu, and then you will choose number 5, which is the intersect, and you'll find that your two x values where these two functions intersect are -0.2749 and 7.2749. Okay, so starting with chapter 2, we're going to be talking about functions. Today we're going to be learning what a function is and different ways we can represent functions and how to evaluate functions. Okay, so functions are all around us. In a lot of cases, we see where something depends on something else. So here we've got height is a function of age. So as people get older, their height gets more. So the height is depending on the age. So what we have is along the bottom here, we're going to have what's called our independent variables. And along the vertical axis, we're going to have our dependent variables because the height depends on the age. So same thing here with temperature and the date of the year that it is. So here the date, the temperature depends on what day of the year it is. Here the postage that you pay at the post office is dependent upon the weight. And so this would also be a function. So we see different ways functions can be represented as well. Some other examples, we've got the area of a circle is a function of its radius. So the area of a circle is going to depend on the radius. The number of bacteria in a culture is a function of time. So the more time that elapses, the more bacteria we're going to have. The weight of an astronaut is a function of their elevation. The price of a commodity is a function of the demand for that commodity. So we've got different variables that depend on other variables. So we have this independent and dependent relationship between the two. So our definition of a function f, and f is a common notation for function, is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. And we'll see kind of go through some examples of what this all means. A couple notation, although f is the most common representation of a function, G and H are also used to represent functions at times. And so it's just a rule that's being assigned to that particular letter. So F's rule might be to square the number. It could be lots of other different rules. So every function has a different rule assigned to it. And so a function F is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. So some notation, this you'll see quite often is read f of x, and you may hear it said f at x. I typically say f of x as far as reading that goes. Okay, and now we mentioned independent and dependent variables, and basically the dependent variable is the one that depends on the other variable. So if you're thinking of a function as a machine, it's going to be like you put something in And then the function itself does something to the input and it gives us an output. So the function has an input x, and this is its independent variable. It does something to it and then it puts something out, and that's the dependent that's coming out as the output. So you've got x going in and f of x coming out of that. Okay, here's an indication with some diagrams. We've got for it to be a function, you can have only exactly one output assigned to each input. So here we've got the number 1 is assigned to 20, 2 is assigned also to 20, 3 is assigned to 30, and 4 is assigned to 40. That's okay to do because each input is assigned to exactly one output. So we're not seeing 1 be assigned to 2 different outputs. It's assigned to one output. If you look over here, 2 is being assigned to 20 and to 30. And so this would not be a function because 2 cannot be assigned to 2 different values. If we were to write these as ordered pairs, this is kind of what you would see with ordered pairs. When you have a listing of ordered pairs, as long as the x's don't repeat, so here's our x's, as long as they don't repeat, it's going to be a function, so that one would be fine. If we look at this one, our 2's repeat, which means the input is being assigned to 2 different output values, and that's why it would not be a function. This last one here, we actually have 2 different x's that are assigned to the same y, but that's okay. Our y's can repeat, but our x's cannot repeat. Okay, so it goes to evaluating a function. Basically, when you're given a function, this is like the rule for that function here. We can plug anything into it that fits within our domain, and we'll talk about that a little bit later. But everywhere there's an x, this is a place that we're going to substitute something. Okay, so that's why it's kind of got these boxes here. Everywhere there's an x, you're going to be inserting a value into it. So like on this one, we're going to work with f of x equals x squared plus 4. So we're asked to find f of 3. So that's going to be 3 squared plus 4. So 9 plus 4 is going to give us 13. If I look at f of negative 2, that'll be negative 2 squared plus 4. So 4 plus 4 will be 8. And then f of the square root of 5, I'll have the square root of 5 squared plus 4. So that's going to be 5 plus 4, or 9. Okay, here's one for you to try. So I want you to try evaluating this one. Remember, you have to substitute it for both places where the x is. So go ahead and try each of these and come up with the value for each function. Okay, this is what you should have gotten. Remember, you need to substitute it both for the x and for this x and for this x, and simplify those, and you'll get your answers from each of those. I think this is fairly common, something that you've seen before, so I'm not going to spend a ton of time going through it. If you are having trouble and haven't seen it before, feel free to reach out to me and I can give you some further instruction on it. Okay, piecewise defined functions. These are important functions because sometimes a function is defined by different pieces, literally, hence the name piecewise defined functions. So this one has 3 different pieces. The first piece is actually a parabola or a quadratic function. The second piece is a line, and the third piece is a horizontal line here. These are our domains. If we look at the domains over here, so basically, if my input value is less than or equal to negative 1, I'm going to use the first piece. If it's between negative 1 and 1, I'll use the second piece. And if it's greater than 1, I'm going to use the third piece. So these are kind of the instruction guide for which function I'm going to use here, which piece of the function. So the first one, if I'm going to find f of 4, I'm going to look over here, and 4 fits in this piece. And so because of that, my value is negative 1. There's nowhere to substitute an x, so I'm just going to give negative 1 as my answer. And you can see that's what we should have gotten here. The second piece, or the second problem we want to find is f of 0. 0 fits into the second piece, so I'm going to plug 0 in for x, and I'm going to get 0 for my answer. The third one, I want to find -3. -3 fits into this first piece here because -3 is less than or equal to -1. So I'm going to go and evaluate this at -3. I'm going to get 9 minus 6, or 3, for my answer. And then finally, f of 1. You have to be careful here because 1 is actually included in this last piece. So the last piece tells me that my function value is -1, and so that should be my answer there. Okay, here's another one. I'm going to let you practice with this one. This is actually a cell phone plan that has a basic monthly fee of $39, and then after your 2 gigabytes of free data, you're charged $15 per gigabyte for any additional data used. And so that's where we're set up with this piecewise defined function. So I want you to try evaluating these three functions here, 3 function values, and come up with your answer. Okay, the first one, you want to, for 0.5, you're going to plug it into this first piece here because 0.5 fits here. So my answer will be 39 for this one. If I'm plugging in 2, 2 is actually going to fit here as well. So my answer would be 39. And then 4, if 4 is going to fit into the second piece. So I'm going to have 39 plus 15 times 4 minus 2. So that's going to be 39 plus 30, which gives me 69 for my answer. Okay, net change is another important concept that we want to look at, and we'll be building on this and looking at average rate of change coming up before long, but for now we just want to look at net change. Net change is how much our function changes over an interval, and this interval would be from A to B. So if I look at this example, if my function is f of x squared, we want to look at it from 1 to 3. So this will be my A, this will be my B. So my net change is going to be f of B minus f of A. So f of 3 minus f of 1. So I need to identify what f of 3 is. So if I put 3 in here, I'm going to have 3 squared. F of 1 is going to be 1 squared. So this will be 9 minus 1, or 8, for my net change. If I look at this next one, I'm going to do, again, f of B minus f of A. This is my A and my B. So I'll have f of 2 minus f of -2. So 2 squared minus a -2 squared. I'm going to have 4 minus 4. So I'm going to end up with 0. So I actually have no net change between -2 and 2 for this graph here. And if you think about it, this is actually a parabola. It's symmetric about the origin, or about the y-axis. So if I look at -2 and +2, if I've drawn this to scale, then there is actually no change in value from one side to the other side, and that's why we get no net change. Okay, here's one that we're going to start, and we're going to evaluate this using A's and H's. So I do want to go through this with you here. This just says that in place of every x, I'm going to substitute an A. So I'm going to have 2a squared plus 3a minus 1. And that would be my answer for part A. Part B, I'm going to take the same thing but put a -a in. So it'll be 2 times -a squared plus 3 times -a minus 1. So this will be 2. A negative squared will be positive, so 2a squared minus 3a minus 1. Okay, this one gets a little bit more complicated because I've got to put in a plus h everywhere there's an x. So I'm going to have 2 times a plus h squared plus 3 times a plus h. And then I'm going to subtract 1 from that. So everywhere there's an x, I put in an a plus h. I want to simplify this. So the first thing I'm going to do is multiply this out. Here I can go ahead and distribute. Okay, this, before I distribute the 2, I want to FOIL this. So I'm going to have a squared plus, if I do inner and outer, I'm going to have 2ah plus h squared. Okay, so this gives me 2a squared plus 4ah plus 2h squared plus 3a plus 3 minus 1, or sorry, 3h minus 1. Okay, and that would be our answer because we don't have any like terms that we can combine together with that. I'm going to have to wait on the next screen to be able to do this, but one thing I'd like for you to notice is that this f of a plus h is actually this first part here. So we're going to come back and use part of that, and then we'll have this other parts here as well. Okay, so this is what we've got to do. We've got to plug all of this in. So I'm going to have 2 times a plus h squared plus 3 times a plus h minus 1. And then I'm going to subtract from that where I plug a in. So it's going to be 2a squared plus 3a minus 1. And then all that will be divided by h. Okay, when we simplify here, I'm going to kind of repeat the same process that I did before, just simply because it's on the other screen and I want to have it all here together. Here I'm going to distribute the negative through. We'll FOIL this out, and this is all over h. Okay, one thing you'll notice is we do get some cancellation here. So the 3 a's cancel, and the 1 and the negative 1 cancel. So I'm going to have a 3h minus a 2a squared, and that's all over h. So we'll keep simplifying. We'll distribute the 2. Okay, so we want to get rid of these 2 a's because they cancel each other. So I'm going to have 4ah plus 2h squared plus 3h. I'm going to divide that by h. So I know you're thinking this is a long problem, and it is long. We're almost there though. If you notice, we have a GCF in the numerator, so I'm going to take that out. So at this point, we can cancel those h's, and we're going to be left with 4a plus 2h plus 3. Okay. And so that should be what you get for this answer. Okay, the domain of a function we've talked about before, so I'm not going to say a whole lot about it, except just remember the domain is your input values, and it's your independent variable. So that's what you're putting into the function. So it's important that you understand that there are restrictions sometimes on what can go into a function. So I'm going to come over here to these rules for now, and we've talked about these before, that you want to make sure that your denominator is not going to be 0. So we'll need to exclude the value that makes it be 0. The other thing is we can't take the square root of a negative number, so we're going to have to make sure that anything underneath the radical is going to be positive. So those are kind of the two things we're going to need to focus on. If we look at this first one here with these examples, this first one we're going to take out an x in the denominator. So we have 1 over x times x minus 1. So we want to consider what is it that would make our denominator equal to 0, and we need to exclude those. So I'm going to set this factor equal to 0 and set this factor equal to 0. So I get x equals 0 and x equals 1. So these are the two numbers that if I plug them back in are going to cause 0 in the denominator and a division by 0 error. So my domain is going to be the set of all numbers except 0 and 1. This could also be written as negative infinity to 0, 0 to 1, and then 1 to infinity if you wanted to write it using interval notation. Okay, if we look over here on this one, this just got something underneath the radical. We need to make sure that what's underneath the radical is either 0 or positive. So we're going to set it greater than or equal to 0. We can't just go in and move the x and take the square root because it's an inequality. So what we want to do is to factor this. And it factors as the difference of squares. So if you remember, when we have a quadratic inequality, we have to find our cut points. So we'll set each factor equal to 0. And we'll find that our two cut points are -3 and 3. Okay, so if we try our factors, so we had 3 minus x, 3 plus x, and then 3 minus x, 3 plus x. Okay, when we plug in a test point, maybe our test point is -5. If I put -5 in, 3 minus a -5 is going to be a positive. 3 plus a -5 is going to be a negative. So a negative times a positive is going to give me a negative for this interval. If I choose 0 as a test point here, and I put 0 in, I'm going to get a positive and a positive. So a positive times a positive would be a positive. And if I try something larger than 3, let's say 5, 3 minus 5 is negative, 3 plus 5 is positive. So negative times a positive is a negative. Okay, here I need it to be greater than or equal to 0, so that tells me I need to choose this positive region here. So my answer is going to be -3 to 3, and I'm going to have brackets on either side of it. Okay, the last one over here, I've got a combination of a denominator and a radical, so I want to take what's underneath the radical here and make sure that it's positive. So I'm going to do t plus 1 is greater than or equal to 0. So t has to be greater than or equal to -1. The only problem is if I put -1 in here, I actually get division by 0. So I'm going to have to do away with that part and just say t is greater than -1. So I'll do -1 to infinity. And that would be my domain. So remember, the domain is like the instruction manual. It's saying what you can put into it. Like for this first one over here, you can put anything except 0 and 1 into it, and you don't get any problems. Over here, you can put any numbers between -3 and 3, but if they're not between -3 and 3, you're going to be taking the square root of a negative number, which you can't do. Over here, any number between -1 and infinity will work, but any number that's not in that interval is not going to work for this function. It's going to give you an error. Okay, there's 4 different ways you can represent a function. We're not going to do a whole lot with this, but I did want to mention it. Verbally, you can represent a function just in words. So like in this example, you convert from Celsius to Fahrenheit, multiply the Celsius temperature by 9/5, and then add 32 to it. So we're describing the function in words, and that's one representation of a function. The other would be a formula. So you can see it here, any algebraic formula would be considered a representation of a function. Graphs can represent functions, and then tables can represent functions. So there's lots of ways you can represent functions. All right, here's some problems to practice on that are like the ones that we talked about today. Okay, the first one, you can see that if you plug these values in, these are the answers that you should have gotten here. And then the second one, you're going to plug into the different parts of the piecewise defined function. So for f of -2, you're going to use this first piece. For f of -1, you'll use the first piece again. F of 0, you're going to use the second piece. F of 1 is going to be the second piece, and f of 2 is going to be the second piece. And you can see what you get when you plug those in for the different pieces. Okay, here we've got net change. So you've got your f of b minus f of a for that one, and it should give you a net change of 12. And then for number 4, you have the function f of x equals 3x minus 2. So to find f of a, you're just going to put a in for x. For f of a plus h, you'll put a plus h in for x. So you replace this whole x with a plus h. Simplify that. And then if you're asked to find f of a plus h minus f of a over h, this one you just found here. So just take this and put that down here, and then minus your f of a, which is up here. You'll get some cancellation, and then you'll be left with 3h over h. Your h's cancel, and you're left with 3 for your answer. And then on number 5, if we look back, number 5 was asking you to find the domain of this radical. So we want to make sure that the t plus 1 is positive or 0. So we'll set it greater than or equal to 0 and solve it. And it is okay for it to equal -1 this time, so we're going to keep the bracket on that. And it's okay because -1, you can take the square root of, you can take the square root of 0. So if I put -1 into this, then you'd be taking the square root of 0, and that's not going to give you an error. It gives you an error when you take the square root of a negative number. Okay, that's it for today. Hopefully you recall having worked with functions before. We'll get into these more over the next couple weeks. And if you have any questions, let me know. Have a good afternoon.